Alright, let's begin. Guys, pull it. I wasn't talking to you. Talking to the class in general. Alright. Motion is a change in position measured by distance and time. Speed tells us the rate at which an object moves. Velocity tells us the speed and direction of a moving object. And acceleration tells us the rate, speed, or direction changes. So describing the motion of an object is occasionally hard to do it in words. We can usually indicate it better using a graph. So there's going to be two main types of graphs. Distance time graphs. We will be plotting time on the x-axis, the bottom of the graph. The further to the right, the longer the time from the start is. Distance is plotted on the y-axis, the side of the graph. The higher up the graph, the further away from the start. So if an object is moving, a horizontal line is shown on the distance time graph. Did you stop that? The time is increasing to the right, but its distance does not change. If it's not moving, we say it's at rest. So it's staying at the same distance. We say it's at rest and not moving. Its distance is not changing. So, if an object is moving at a constant speed, it means it has the same increase in distance in a given amount of time. Meaning that if it goes for like 1 second, it travels this amount of distance. If we look over here, if we do another 1 second, it's done the same amount. So this length is the same as this length, or the same amount right here as here. So time is increasing to the right and distance is increasing in a constant line. If it's a constant line, it means it moves at a constant speed. Constant speed is shown by a straight line on the graph. When we compare two objects, both of the lines in a graph show that each object moves the same amount of distance. But the steeper dashed line got there before the other. So if I were to say this was the finish line, this one reached there in this amount of time, and this one took longer. A steeper line indicates a larger distance moved in a given time. In other words, higher speed. So both lines are straight, so both speeds are constant. So the steeper it is, the faster it's moving. Acceleration looks like this. Graphs that show acceleration look differently than those that show constant speed. The line on the graph is curving upward. This shows it's an increase in speed. So we're going from less steep, and we're increasing the steepness of the line. In other words, at a given time, the distance the object moves is changing. It's getting larger. It's thus accelerating. So a distance time graph tells us how far an object has moved with time. The steeper the graph, the faster the motion. A horizontal line means that it's not changing its position, it's staying the same distance away. It is, in other words, at rest. A downward sloping line means that the object is moving toward the starting location. So here we see a very steep line. It means it's moving fast. See a normal line still moving at speed. Here we see that it's staying at the exact same spot, the same distance away from the starting location. Here it's moving back toward the start. So here it might go from 0 feet to 10 feet. And then from 10 feet, it starts moving back down to 0 feet. And the curve indicates that it's getting faster and faster. So you might be jogging, then you start, or you start out walking, then you start jogging, then you start running. So, which of the graphs shows that one of the runners started 10 yards further ahead of the other? A. So we compare the starting point. So this one started at 0 yards and this one started at 10 yards. So in A, one started at 0 yards, the other 10 yards. So they are 10 yards minus 0 yards, which is 10 yards apart. For B, they start both at the 10-yard position. For C, they're 20 yards apart. And at D, they both start at 0 yards. In which of the following graphs below are both runners moving at the same speed? So which ones are they moving at the same speed? It would be D. They're the same slope. So same slope. How fast are they both moving? So here we can see that this line started at 10 yards and moved to 20 yards. So his distance is 10 yards. And he did it in 4 seconds. So speed is equal to distance over time. And so it would be 10 yards for 4 seconds. And that would be 2.5 yards per second. And this one does the same thing. He also goes 10 yards. And he does it in 4 seconds. No. This is a note. So we look at this line. He goes, or better yet, let's do another one. Let's look at this line. So he goes from 20 to 30 in 4 seconds. So this distance right here is 20 yards. So he goes, and remember speed is equal to distance over time. So that would be 20 yards over 4 seconds, which would equal 5 yards a second. So this person was running twice as fast as these two people. Yeah. I put videos online. You can also come after school for tutorials. Or before school, during lunch, during my conference period. So, the distance time graphs below represent the motion of a car. Match the descriptions with the graphs. So, graph A matches which number? Yeah, graph A matches which one? So, the constant speed. And we know this because it's a straight line. Positively sloped. That's not really. Yeah. Which one does B match? So he's some distance away and he's returning back to the start. We also know this because it's a negatively sloped line. It was a circle. So it's negatively sloped. Which one does C refer to? Does this be 1? We know this because it's flat or horizontal line. So the last one is obviously the only one left. The speed of the car is decreasing. We know this because it is curved. So when you see that he's going really fast here, he's beginning to slow down and he comes to a stop. So this is speeding up. If you look like this, it's speeding up. Stop clicking your pen. Slowing down. Looks like that. By the way, the code word for remote learners is beta. So now let's look at speed time graph. Dylan, face forward and pay attention. Speed time graphs are also known as velocity time graphs. Speed time graph looks much like distance time graphs. Make sure that you pay attention what the label on the graph is. So they'll be labeled. A straight line, speed or velocity is going to be on the y-axis. A straight horizontal line on a speed time graph means that the speed is constant. So it's at some speed right here. A straight line does not mean the object is not moving. In a distance time graph, it does, but in a speed time graph, that means that it is staying at the same speed. So the graph this graph shows an increased speed. The object is accelerating, so the speed is increasing. So this could be like 0 miles per hour, and it's going up to like 100 miles per hour. So the speed is increasing, that means acceleration. And if the speed is decreasing, that means deceleration. So so when you're comparing two moving objects, it tells you that the more steeper it is, it means the faster the acceleration. So they both reach a top speed, the same top speed. Maybe it's 100 miles an hour, but this one does it in less time. So in summary, a speed time graph shows us how much the speed is changing. Did you stop clicking your pen? Both of y'all. Which one of y'all are doing it? The steeper the graph, it's you beating. It's you beating. You're doing this. Huh. So the horizontal line means the object is moving at a constant speed. A downward sloping line means the object is slowing down. So here the acceleration is increasing, or it's doing a steady acceleration. The speed is changing. Here it's staying at constant speed. So perhaps you started at 0 miles per hour and you increased your speed up to 40 miles per hour. And you stayed steady at 40 miles an hour. And then it increased up to 50 miles per hour. Maybe you tried to pass someone, and then you realize you're about to miss your turn, and you slammed on the brakes and decreased back down to 0 miles per hour. Alright, so let's look at these. Which one does E correspond to? So traveling at a constant speed is which one? Which number? 7. Okay. So you said second. So the car is accelerating. It's because it's a straight line. Straight, positively sloped line. What about F? So we're slowing down. It's a negatively sloped line. What about G? So this would be flat uh, horizontal line. And H is obviously 5. So a car is stopped. because it's at 0. Has 0 speed. Everyone good? Alright, so let's do some examples. First step, when you see a graph, is it a distance or speed? This is a distance. First thing you should do is check to see if it's distance or speed. So look at the graph above. It shows 3 runners that ran a 100-meter race. Who won? So Albert finished first. He finished in 12 seconds. So he was faster than the others. Which runner stopped? So Charlie. He stopped between here and here, so we know this because there's a flat line. There's a flat line in his motion. How long did he stop for? So he stopped between 8 and 13. So it was 5 seconds. He stopped between 8 seconds and 13 seconds. How long did Bob take to complete the race? So it took him 14 seconds. That's because he reached 100. So it's whenever he got to a 100-meter mark that he did it in 14 seconds. So it's not just that he reached the top of the graph, it's the fact that he made it to the end of the 100 meters. Yeah. So what was Albert's average speed? So average speed is equal to total distance divided by total time. So his total distance was 100 meters, and he traveled it in 12 seconds. So he went 100 meters in 12 seconds. So 8.333 meters per second. Alright, one more. Now I'll pass out homework. So segment 0 to A is what? So 0A is accelerating. Again, the first thing you should be looking at is the fact that this is speed. So A to B is what? It'd be constant. So this is constant. He's not changing. His speed is 10 meters per second. So it'd be constant speed. Between B and C, and between C and D, so speed is 0. So is at rest. And between D and E, what's up? No, but what is it doing between E and F? No. Constant. It's a constant 5 meters per second. At rest would mean 0. So I meant to give this out tomorrow. And then you'll get a 0. This will be due Monday when we get back. Then it's a 0. Or you can sit over here and finish it now. I already had some people turn it in.